Sound waves, like any waves, can be made to interfere. For sound, a wave crest is a compression and a trough is a rarefaction. When the crest of one wave overlaps the crests of another, there is constructive interference. When the crest of one wave overlaps the troughs of another, there is destructive interference. A listener that is equal distance from two speakers that trigger identical sound waves of constant frequency hears louder sound. The waves add because the compressions and rarefactions arrive in phase. If the distance between the two speakers and the listener differs by half a wavelength, rarefactions from one speaker and compressions from the other arrive at the same time. This causes destructive interference. Listen to the following sound using speakers, not headphones. When you move your head from side to side, you should hear the sound getting louder and quieter. The loud spots are constructive interference, and the quiet spots are destructive interference. In normal situations, many frequencies are being played at once, and you don't notice the constructive and destructive effects. Destructive interference is used in anti-noise technology. Noise-canceling earphones have a microphone and circuit that reverse the phase of the noise and destructively cancel it out. When two tones of slightly different frequency are sounded together, the sound is loud, then quiet, then loud, and so on. This periodic variation in the loudness of sound is called beats. The vibration of the forks will be momentarily in phase, then out of phase, then back again. When combined waves reach your ears, you hear a maximum. When the forks are out of phase, you hear a minimum. If you've ever sat at a light waiting to make a turn with your blinker on, you may have noticed the car in front of you has a blinker with a different frequency. The blinkers will be in phase and out of phase, just like beats. When one tuning fork has a frequency of 264 times per second and the other has a frequency of 262 times per second, the frequency of the beats is 2 Hz. To find the beat frequency, subtract the frequency of the higher sound from the lower sound. It's important to know that when the difference between the frequencies is too big, you won't be able to distinguish a beat frequency. Also, if the difference between the frequencies is 0, there will be no beat frequency. If you overlap two combs with different teeth spacings, you'll see a pattern that is related to beats. Beats are a practical way to compare frequencies. A piano tuner will play a tuning fork and a piano string together. They then tune the piano string until the beat frequencies disappear. Now they have the same frequency.